Hi, everyone. I am Matthew Gerstman, and today we are going to discuss TypeScript. And I realize this talk kind of sounds like I'm about to go on an indictment of TypeScript, but actually I love TypeScript. I adore TypeScript. I just want to kind of talk about it holistically to convince you that it is worth your time. So who am I? My name is Matthew Gerstman. I am a software engineer at Dropbox. I live and work in New York. You can find me on Twitter. And for some reason, people think following me on Twitter is a good idea. So I'm going to tell you why that's a bad idea. First of all, I tweet a lot about Taylor Swift. This is me whenever I go on a bad date. I also tweet a lot about Harry Potter. This is a replica of me as a teenager, just very angsty. And finally, I wrote a book on how to buy Broadway tickets, and that is my shameless plug. So thank you for indulging me. Let's go to TypeScript now. So the reason I put this talk together was at the beginning of the year, I noticed a lot of Twitter chatter about TypeScript. People were really, really excited about TypeScript. People were saying that their New Year's resolutions were to learn TypeScript, and someone was like, hey, it's been 2 weeks. We should all be experts by now, right? Because that's how tech works. And then someone's like, I'm going to try to embrace it. I really appreciated how Jane Wong stepped in and was just like, why is everyone saying this? This kind of came out of nowhere. And it wasn't just Twitter, right? It was Quora and Reddit and like Medium and just anywhere you could write an opinion, someone was writing about TypeScript. But this actually isn't new at all. This is the Google trend for TypeScript interest over the past 7 years, so since 2013. And you'll see it's been steadily increasing in popularity since then. So this isn't really new. And something I've seen a lot of is people like to compare TypeScript to CoffeeScript because they're both popular languages that add some fundamental new thing to the language that compile down to JavaScript. But CoffeeScript was 3 years old when it died, whereas TypeScript is turning 7 soon. So I don't think we can meaningfully compare them anymore. And CoffeeScript, I know a lot of people like to talk about it, and like poorly now because it's just legacy code, but that's what gave us promises, that's what gave us lambdas, it gave us a lot of really interesting things at the time. So today, I want to get past the hype. And the reason for that is I think when we are talking about our tools, we spend way too much time looking like this. And instead, we should really be looking like this. By the way, do I have any Futurama fans here? Yeah, sweet, cool. I will not. So we're going to go into the ugly parts, and then we're going to talk about why I think you should use it anyway, because I want to convince you that this is a tool worth using and learning. And frankly, that's not going to happen if we don't talk about like the bad parts of it. So let's take 10 steps back first. What is a type? Well, a type is an attribute of data that tells the computer how the programmer intends to use it. And even if you don't work in TypeScript, you're probably familiar with some basic types in JavaScript. We have booleans, which are true or false. We have numbers, so 1, 7, 3.5, whatever it is. We have strings, which are groups of characters. It could be the entire text of Harry Potter, which I would put in a string. We also have arrays, which are lists of things. And we have objects, which are maps. These are all types that I hope you're familiar with. We also have some falsy types, right? Most of you have dealt with something with null or undefined being different. And TypeScript decided, hey, let's make this a little more confusing and add never and void, which we're not really going to cover today, but no, they exist. Types can also be derived from other types. So we can do things like say the type of this is only one of these specific strings, like it's an enum, or we could say it's an object of this shape. And the final thing I need you to know about for TypeScript types is any. And what any is it's an escape hatch. It basically says, hey, TypeScript, you don't know how to type this, or I don't know how to type this, but either way, I really don't want you to do anything here, so just trust me. I'm a doctor. I got this. So what exactly is TypeScript? Well, TypeScript is a strict superset of JavaScript. Strict might need a little asterisk now because someone came up with a nifty little counterexample, but let's go with it's a superset of JavaScript. And it looks like this. In fact, if you look at this code, the only thing that makes this different from traditional JavaScript are these type annotations right here, these strings and booleans. So I have a function that takes a string and if I run this code in my editor, or if I compile it using TypeScript, it will work just fine when I pass it a string. But if I pass it a Boolean, it's going to fail. By the way, Gryffindor is for people who peaked in high school. I have very strong opinions. TypeScript is also smart, like really, really smart. So we have these DOM functions, document.getElements by tag name. And we need to pass it different strings and return different types of elements based on what type of string we pass, right? Because A tags have hrefs, whereas divs don't, and P tags have their own attributes. So we want to return a completely different type based on what string is passed to this function. TypeScript also makes big refactors really easy, and that's where I'm going to show you some of it. So let me switch into, let me demirror for you. Cool. So I have this code here, and you can see I have a list of Slytherins. I said I was a big Harry Potter fan. And in what we're doing is we have Taylor Swift, who I've already told you I love. We have Lin-Manuel Miranda, who wrote Hamilton, which is a great musical. And we have Severus Snape, who is kind of a pain, but he's famous. Thank you. And let's say we want to add a prop. We want to add a points prop. So we're gonna put points here, and we are going to type that out. And this is super cool. VS Code immediately picks up that it can't find this variable name, which it could probably do in traditional JavaScript. I don't know. We'll ask Brian afterwards. But that's not really TypeScript specific. So let's add it to our function signature. Now, this is where we have an actual TypeScript error. Property points does not exist on type props with children, Slytherin props. And this is the type of error message that you have to learn how to read. But what this is effectively saying is Slytherin props, which is right over here, does not contain points. And this is probably the coolest thing about TypeScript, in my opinion. If I add this prop, you can see the second I type a P or any letter, it lit up at the bottom with this red. And the error message here is that we are missing the property points on all of these components. And if you consider, these are all in this file, but imagine if I had my component library on one side of my application and their usages on the other. You will catch these things very, very quickly. So let's give out some points, shall we? So Taylor Swift currently really just had a great album. I'm very proud of her. So we're going to give her a whole bunch of points. Lin-Manuel Miranda is literally printing money at the moment, so he can have more. And I don't like Snape, so he can have -3 points. Cool. And by the way, if you were curious, if you want to know what happens when you take this stupid little example and turn it into a fully fledged website, you end up building this, slytherin.dev, which I did for another talk for fun. Fun fact, Brian is not mentioned here because he is a Ravenclaw, but his wife, Nikki, who is present, is there. And also, Nico, one of our other great speakers, is on here as well because she is a Slytherin. So that's just fun, and I wanted to share that. Now, let's talk about vanilla JavaScript, right? So TypeScript claims to be incremental, and it is, especially at first. So if I want to make a string, Muggle, Vernon Dursley, or just Dursley, and if I want to do yelling Muggle, const yelling Muggle equals Muggle, you'll see I immediately get dot completion on every function that's on this string because I'm using TypeScript. That's the kind of thing that you don't have right away. So let's call 2 uppercase, which is great. And let's say I want to get a subset of this string, right? I want to call slice. But let's say I make a typo. I type splice. Well, it gives me the great error, property splice does not exist on type string. Did you mean slice? And that's the kind of thing that just like is amazing that when you get to start taking it for granted, because I could have easily made this typo, right? And then that would have appeared in my browser as opposed to in my editor, or even, if I'm lucky, my terminal. So we've got that, but these are just strings, right? Let's do something a little more complicated. Let's make a wizard. So we have a wizard, and we want to do wizard.name equals Harry Potter. Well, this is interesting. This is totally valid JavaScript this time. And it says property name does not exist on type empty object. That's a little obnoxious. OK, so let's fix that. So let's make a type. Let's make a wizard type. And wizards have names, so we'll do that. And we will add the type annotation. And now we get a new error. Now it's saying property name is missing on type empty object, but required in type wizard. So OK, so we have to do it this way. We put the name in the thing. And even though every example you just saw was totally valid JavaScript, TypeScript is making us do it this way, just because it needs to infer these types. Let's look at another example. How many of you use LODASH either willingly or begrudgingly? Yeah, most people use LODASH for something, right? So we import LODASH, and we get the same super cool doc completion on LODASH, which is an external library. And I think LODASH is a particularly cool example because of how powerful the types are here. So you'll see right now it thinks that I might want to pass a collection of strings to this. But the second I give it an array, it's going to assume that it is something array-like, and it could be anything. And when I start typing numbers, it knows that it's a number. And if I type string, it knows that it's a string or a number. So not only that, but in my predicate, it knows that value is of type number. So if I add slice to this, it's going to say it doesn't exist on number. So let's just make this work for values greater than 10. Cool. Doop. Sweet. By the way, Slytherin.dev was the thing I showed you. So one of the takeaways I want you to have is that TypeScript is going to get in your way for the first few months. How many of you have used one of these functions, lodash.get or lodash.set? Yeah, they're kind of becoming less popular, especially as optional chaining is a thing, but these are virtually impossible to type. Getting the type, so these allow you to arbitrarily drill into an object via a string and just kind of do something there. And it's really hard to get that right in TypeScript, and we're just going to kind of give up that tool. What about tests, right? Like, we have to write tests. Tests are going to require very well mocked data, or you're going to be using lots of any's. What if you want to test the absence of a prop on a component? Especially if you're writing a library, like where you don't know how your consumers are going to use it or if they're going to be using TypeScript. You're going to have to start throwing in any's. What a lot of things come down to is advanced JavaScript ends up translating to advanced TypeScript. An example I love to give are higher order components. How many of you are still using higher order components? Yeah, it's like they're not as popular as they used to be, but they are one of the most interesting type cases, I think, because we have a wrapped component, which is inside of the HOC. It's receiving props from it, and then it also needs to receive regular props from the outside, which may or may not need to be read by the HOC. And just to make this more complicated, the wrapped component internally needs to be able to receive all the props it knew about, and then also the HOC props. This is really, really hard to type. You need to know about generics. You need to know about intersections. You need to know about discriminated unions. And I don't expect you to know any of those things today. You just want dot completion on your strings. Like, that's what you want early on. So if you are interested, I wrote a blog post. You can check that out on how to type a higher order component. It took me 2 weeks in 2017 because there wasn't a lot of documentation back then. The other thing is TypeScript is not sound. So what do I mean by sound? Well, soundness implies that we can know at compile time that our code is safe to run. And if it doesn't have that property, it's considered not sound. And the reason for this is anyone can put an any anywhere in your code base. And remember how I said any is just like a trust me, I'm a doctor, it's an escape hatch? It's actually a little more like this. Glad I got something. Cool. Anyway, so a great example of something that's very hard to type is React context. So we have a provider and a consumer and this magic data flow in the middle. And we can't really type that magic data flow. We can trust that React's going to do the right thing, but the best we can do is pin the type on the provider and on the consumer and hope for the best. React Redux takes this problem to the next level. We have to deal with context, and then we have funcs, which are functions returning functions, and inferring what each of those levels return. And then when we're dispatching with middleware, we're doing all this complicated typing, and it just starts to get really challenging. And all of this is because TypeScript is a strict superset of JavaScript. We're bolting on types onto an untyped language. This is totally valid JavaScript. It's stupid, but it's valid. So this function, if it gets Harry as an argument, it returns 7. If it gets Ron, it returns undefined. If it gets Hermione, it returns an object. And if it gets anything else, it returns wizards. And you may be thinking, why would I write a function that returns 4 different types? But I actually showed you that at the beginning of the talk. Most DOM APIs will return one of many different types based on what string you pass to it. They're just not all as contrived as this one. So here's where I tell you that all of this is still worth it. TypeScript is just another tool. TypeScript is not a silver bullet. And what it does do is it eliminates an entire class of bugs. How many of you have seen this error message in your console? Just like expect the entire audience to raise their hands. Right, of course. Like at some point you've seen this, and 9 out of 10 times, TypeScript's going to cut this out for you because it's just going to know undefined is not there when you try to access that property. Same thing for this one. When you try to call a function that isn't there, it's going to catch that in your editor with those red squiggly lines. And not just like these things. What about when the interface changes? What about when I add a prop to a component that someone else on my team is using and I forgot to tell them? It's going to tell me in advance when this happens. And this becomes an even bigger issue when you're talking about the scale of a company like Dropbox. We have hundreds of engineers working on the same code base. We have millions of lines of TypeScript, hundreds of features, and just to make it more challenging, we have 4 engineering offices in 3 time zones. So we have to coordinate well. TypeScript is a core part of our front-end workflow, and I want to show you some cool examples that you might not have thought of. One of my favorite ones is library upgrades. So there's this great typings library on GitHub called Definitely Typed, and what exists here are all of these types for any third-party library you can think of. If it's not in the library itself, it's almost definitely undefinitely typed. And the first thing we do when we go to swap out to upgrade a library is we swap out the types. So let's say we're going from React 16.10 to 11. We will swap out the types, and then if there are any breaking changes in the API, we'll catch those almost immediately because it'll be in the typing layer and our compile will fail. So the very first thing we fix is compilation. Some examples of the types of things that change are what happens when a feature gets deprecated, what happens when we lose old context, or we get rid of old refs, or we get rid of component will do something. And then also the types are changing, right? Like sometimes function signatures change. Sometimes we add something or remove something. And then often the types just get better. A lot of the time someone will bump the types on definitely typed, and they will catch something for us that is just some edge case where undefined was passed somewhere and you didn't even think of it. Honestly, at our scale, I don't know how we would upgrade libraries without TypeScript. We're talking millions of lines. TypeScript also allows us to place constraints on our engineers. And you might be thinking, I don't want constraints on me. I want the freedom to do whatever I want. And I'd like to give you a metaphor. So we have the beautiful Charles Bridge in Prague. And the simplest way, with the fewest constraints to build this bridge, would have been to dump a ton of concrete into the river. Maybe at the time, several hundred years ago, dump a bunch of stone into the river. And that would build a bridge that lets us cross it, but we couldn't have boats get through. We would ruin wildlife. We would do terrible things to the environment. And maybe we shouldn't do that. So when we're building bridges, we do proper constraints, and we want that with our engineers too. So remember how I talked about React upgrades? We often want to test the latest version in production. So we want to make sure that the newest, latest thing is going to run against the code that we have. But we might need to roll back. And here's the problem with that. Developers will start using new features as soon as we let them. Remember when hooks came out? This is a simulation of our web platform team dealing with all of our engineers excited about hooks. They are Simba. They are just trying to stay ahead of the pack to make this work. So to solve this, we roll out the latest version of React behind a feature gate, but we keep the types of the previous version so that at the compilation step, they just can't use hooks until we know that we're not going to roll back. And then once we're confident, we'll add the types. And this process sounds heavy. It lasts maybe a week. It's just, we want to run latest React against 10 or 20 or 30% of our users until we bump it up to 100 and leave it there. Another super cool thing we do is we restrict LODASH usage. So there's a lot of functions in LODASH that are no longer really relevant. They kind of made it into ES5, or they're just like kind of heavy, or whatever. We don't want them. And also, LODASH is 25K if you ship the whole bundle. So you definitely want a smaller bundle. Excuse me. So what we do is we have this typings firewall that prevents engineers from using functions that we don't want in our bundle. And if they want to add it, they submit a PR, and it's a one-liner, and we probably say yes if we think it's a good idea. But otherwise, we just like kind of default to not having this dependency and not sending down this extra code. We wrote a really great blog post about all that and how we did that migration. You can read that one later. But what about for small teams, right? Like, I've been talking about hundreds of engineers, but your team is probably 5 or 10 or 20, or maybe it's just you. Maybe it's just you writing code. And some people are going to claim that TypeScript gives you free documentation. And I'm not going to tell you that. I think you still need docs, especially to convey why you did things. Some people are going to claim that TypeScript is going to give you free tests. And I don't want to make that claim either. You absolutely should be writing integration tests and end-to-end tests and like dealing with that. But here's what TypeScript is going to give you. It's going to give you contract validation across the board. So this is kind of a standard application, right? We have our API, and then we have our data layer, which might be Redux, it might be Apollo, it might be hooks. Well, we might be using hooks, use reducer, whatever. It doesn't matter. It's probably here. Then we have our components, which are a little smarter and are doing some business logic. And then we have kind of our dumber components in the front, our component library. And we can enforce contracts across this. So a contract is a precise and verifiable interface for software components. And the most important part of this is that it's verifiable. So for example, on our API, an engineer who's probably writing in Python or Go or Rust is going to want to make a change to some endpoint. And what we do is we compile those types using a tool that we've open sourced called Stone. And we have TypeScript types then, and they will know immediately before they merge their code if they're going to break someone's usage somewhere on the front end. Similarly, on the entire opposite end of the stack with our component library, if you've got a slithering component and you want to add a prop that is now required, or you want to remove a prop or add the type or change the type, we're going to catch that across the usages throughout our millions of lines of code. And then not only that, but engineers can do this within their own features, which is super nice. In fact, I want to show you an example of that. So I wrote this small sample app. And the first thing you'll notice is that we have this type user. And user has a user ID, which is a number, and a name, which is a string. We have this function, which might be auto-generated from our tooling. It's called fetch users, and it returns a promise of list of users. So we've brought this type from the back end to the front end using TypeScript and automated tooling. In our Redux layer, we're going to want to dispatch actions that can fetch the user. And the payload is going to be of type user. So this type is slowly propagating across the system. Inside the function, we are returning a type which has guaranteed that payload. Then in our actual store, where we're storing the data, we are still using this user type that came from some arbitrary place in the backend. This could have been defined in a protobuf. This could have been defined very close to the database, but we are propagating this across our system. Now here is what I like to call a contract shift, because what we're doing is we are taking the store, or the shape of the store, and that has a user in it, and now we are returning a string. That's what that type on the far right is. So our view, which really doesn't care about the backend or how any of this works, has this name prop, and all it's receiving is a string, and it can just spit that out to the user. So this type, this user type from the backend, is being propagated everywhere it's needed up until we have a contract that says, hey, we need a string for type user, let's trade, and then we give that out to the view. I also like to argue that TypeScript increases in value over time. This is kind of just like a contrived graph where I said the number of lines of code that you could generate by yourself over 3 years, which is probably 20,000, maybe it's 50,000, maybe it's 100,000. You could write a lot of code by yourself. And what happens if the team becomes 5 or 10? You're easily producing hundreds of thousands of lines of code very quickly. Are you going to remember how every part of your application integrates with every other part of your application? How many of you have written a login form at some point in time as the very first thing you did and then forgotten about it? It's kind of a common thing. So what I like is that unlike tests, TypeScript gets in your way. It's in the middle of your editor. It's in the middle of your compiler. Now, it's not a silver bullet. Like I said, I want you writing tests. I want you doing code review. And I want you thinking about architecture. But I would argue that the metric for success on a code base is how few things you need to keep in your head at any given point in time. And TypeScript allows you to forget about other parts of your code base. And really, the only cost is learning it. So thank you so much. My name is Matthew Gerstman, and I think we can do questions.
Thank you, Matthew. We have questions. Do you think duck typing is an anti-pattern?
So one of the interesting things about TypeScript especially is that it uses structural typing. So I've been in cases where I did something like I had two types that were exactly the same, and we decided to split them because they might change. Is duck typing an ANSI pattern? The answer is depends on your use case, like most things. I don't really have a strong opinion here. Chances are, if your UI props and your very back of your stack props or just function signature are exactly the same, they're probably going to diverge at some point and maybe make two separate types. But you can also start off with one. The biggest thing I would avoid is just hasty abstractions, where you abstract things that don't necessarily need to be abstracted.
Why should I choose TypeScript over Flow?
Honestly, I would just push you to use a typed anything. I do not have a stake in this holy war. I work for Dropbox, not Microsoft or Facebook, so I really don't have a stake in it. I can say in my experience, TypeScript has a much stronger community. It has much stronger third-party types, and it seems to be getting more support. But if Flow is working for you, like, I'm not going to tell you to migrate your code base. Keep using Flow.
This one you might have to help me. How much different is TypeScript versus native async await syntax? Shows significantly slow performance with big data structures.
Interesting. OK, so TypeScript does the job for you that Babel traditionally does, which downcompiles your latest ES-Next code with all the latest features into something that the browser can serve. It can even do ES3, but normally it's doing ES5. I actually don't know the performance implications of using TypeScript versus Babel versus the native one. I would imagine that the native async await is probably the fastest one. If you're in an environment where you're really optimizing for that, you could serve the async await as is. But I don't think TypeScript really has much of an impact here compared to any of the other options you're going to choose.
Next is how TypeScript works with not typed dependencies.
Yeah, so if it's not undefinitely typed, which is rare, what you do is you make kind of an index file for yourself. It's called a .d.ts file, and it's similar to a header file in other languages. And what you do there is you say, this is the library, and you have two options. You can either take the time to type it yourself, and maybe you want to commit that to the outside world. Or you can just say, just trust me when I use this library. And it's not going to be type safe there, but that's one of the nice things, is that it's incremental, so you don't immediately have to type your whole code base. It's also really useful to think of this not just for not typed dependencies, but for just parts of your code base that aren't typed. A lot of the time when people do migrations, they tend to start very inside and then move outwards. There was a great talk from someone at Airbnb, I believe, about how they did that migration.
We're going to do last two questions, Matt. So how steep is the learning curve for TypeScript?
So I hope you saw some of that in the incremental step, that at first it's very simple. Like, you have strings and you have numbers and you have primitives. It does get complicated very quickly. Like, you don't have to go from 1 to 11, like on the knob from 1 to 10, but you do get to 6 rather fast. And the reason for that is third-party libraries like LODASH or React or what have you, those are going to require sufficiently complex types to be statically typed. Now, you can always make the trade-off. I want my code to be slightly less type-safe and get some of the benefits of TypeScript. That is totally a valid thing. But if you're going for that like perfect typing all the time, like, yes, there's a steep learning curve. Yeah.
So I said last two questions, but we have two more questions that are both competing. So will there ever be integer type in TypeScript?
Ask Brian Holt after I leave the stage.
And sorry. And Oh my goodness. And then last one, how do you pass generic type into functional components?
Yeah, I do that all the time. So you can do, what you end up doing is you do const, it's easier if I actually type this out, you do const React type variable type of the React component, and then you can pass a generic to it. I don't think you can actually do generics with standard function space name of the function signature, but you can do it with the store it in a variable syntax. So there is one way to do it, but it doesn't work the other one.
All right, that's all the time we have. Thank you so much. That was Matthew Gerstman.
Thank you so much.